What we see above the ground is only a small part of the natural world. A busy, complex web of life lies just beneath our feet. Fossorial animals are well adapted to life underground. They live in burrows, tunnels, and mounds, using the earth or whatever substrate they live in to build their homes, find their food and friends, and stay safe from enemies. In this episode of Animal Super Senses, we find out more about the animals that have their feet firmly planted on or under the ground, and find out how their senses are tuned to survive. For animals that live underground, adaptations for digging deep come with the territory. That includes strong limbs, claws to dig with, and a keen sense of touch. The wombat is the largest burrowing mammal, found in the temperate forest of southeastern Australia. They have stocky, powerful limbs, short necks, and broad, flattened skulls, perfect for pushing through the soil. Their forepaws are used for excavation. They can remove just about any obstacle with their incisors. To expand the sides and roof of a tunnel, wombats twist the upper body and perform barrel rolls. Their front end is backed up by an impenetrable posterior. Wombats have what is called a dermal shield on their rear, a plate of bone, muscle, and cartilage that can help defend their home from intruders. They can seal the entrance with their tough bums, or squeeze under the invader and slam them against the tunnel roof. To avoid the heat of the day, this marsupial stays cool in its burrow. The wombat comes out at night to feed on grass and the roots and bulbs of plants. They are able to pick up the most tender shoots because of a split upper lip. And to cope with their fibrous diet, they have open-rooted teeth that are continuously growing, a feature unique among marsupials. A sense of touch is highly advanced in those that have a habit of living like a hobbit, and the wombat is no exception. Their cheeks, jaws, and wrists are covered in vibrissae, whiskers that are specially designed for tactile sensing. Many animals that live the subterranean life have a need to be in close contact with their surroundings. It's a sense known as positive thigmotaxis. And although wombats' senses haven't been studied too closely, it's likely they have this need to be in touch with tight places too. In the deserts of Central Australia, there are other creatures, many times smaller than the wombat, who also make their home underground. To shelter from the searing heat, rodents escape by burrowing deep into the cracks formed in the gibber, or stone-covered plains. Feeding mostly on seeds during the nighttime, They are perfectly adapted to the arid climate. They get all their fluids from their food. Gibber rodents live in small colonies, keeping in contact with burrow mates using a variety of calls, including squeals, whistles, chirps, and chatters. It's thought that their hearing is best at ultrasonic frequencies, perhaps an adaptation to avoid predators who may be listening above the ground. This rodent is not alone. Its subterranean shelter could be its undoing. Another creature is searching for sanctuary from the sun's heat and looking for a tasty meal. The Inland Taipan dwells in the cracks and crevices of the dry, rocky plains. And lucky for them, their favorite food lives in the same place. Cornering the rodent in its burrow, the taipan strikes with deadly poise. Injecting a lethal cocktail of paralyzing poisons. Its highly toxic venom is considered to be the most potent of any land snake in the world. The venom acts so quickly, the victim has little time to fight back. Food is scarce in the desert, and the snake must make use of every sense to find its prey. Smell tasting is the most important tool for sensing food. The forked tongue flicks rapidly, tasting the air for prey odors. This chemical information is then passed to the Jacobson's organ in the roof of the mouth, and then back to the brain for processing. Taipans can also detect their prey by sensing movement. They can hear by picking up vibrations along the ground. These travel through to the inner ear by means of a chain of bones in the lower jaw. Using its senses in this underground lair, the snake is a supremely adapted killer. Searching for prey certainly tests the sensory limits of animals. But when your food is minuscule and hidden, it really does need super senses to find them. The short-beaked echidna has a specialized diet. It only eats ants and termites found deep under mounds and logs. To get to the insect nibbles, the echidna uses its powerful, stout limbs to dig into the soil and rip open rotten wood. The front feet have 5 flattened claws, and the hind feet point backwards, helping the animal to push the soil away when burrowing. But it is the echidna's nose that is key to its success. Highly tactile, 8 centimeters long and rigid, this fair-sized proboscis helps this spiny anteater forage and poke around for food. The tongue can dart out to a length of 18 centimeters to catch its prey. And with the help of some very sticky saliva, with the consistency of molasses, ants and termites have little chance of escape. The snout is covered with tough, hairless skin containing glands and sensory receptors. Echidnas can detect prey by smell, but they also have an additional sense, found only in a handful of animals on the planet. With the tip of the snout, they are thought to have the ability to sense electricity. Until recently, the platypus and echidna were the only mammals known to use electroreception. Both are monotremes, egg-laying mammals, an ancient order of animals left over as a relic of evolution. The structures responsible for the electric sense in echidnas are sensory mucus glands. It's not fully understood how they use these, but tests have shown they can detect weak electric fields in water. As water is a good conductor of electricity, echidnas may be able to detect moving prey in moist soil. Even with a tough snout, echidnas generally avoid large biting ants for good reason. These nests are usually safe from anteaters. That's because there's a formidable fighter within. Australian bulldog ants are among the biggest and most primitive members of the ant world. They also pack a punch in their venomous sting. Easily recognizable by their huge jaws, bulldog ants use their sizable mandibles to carry food, construct nests, and defend their territory. They are active hunters and ferocious. If an intruder dares to venture near, the colony swarm out and attack within seconds, stinging them repeatedly with their venom. The ant chamber is underground and can extend several meters below the surface. It's here the queen lays her eggs, which hatch into fat, helpless larvae, lavishly tended to by workers. Most ants have poor eyesight, but a few have exceptional vision, and the bulldog ant is one of them. And they need their super sight to keep up with the insatiable appetites of their young siblings. Adults feed mainly on honeydew and nectar, but the larvae are carnivorous. The infants signal their hunger by raising their heads. Worker ants on dinner duty leave the nest and hunt alone, using their large eyes to find prey. Once they find a victim, they immobilize it with a deadly strike and carry it back to the nest. Workers bring dead beetles and bees into the chamber. The larvae attach and feed straight away. In their underground lair, it's important to be in constant contact with nestmates, both adults and young. The ants' antennae are special organs that help them detect chemicals and are also the touch sensor. They are used to identify friends from foe. Such an important sensory tool needs to be kept in top condition, and ants spend a great deal of time preening their antennae. An ant colony is a finely tuned machine with thousands of workers going about their jobs. And it's their super senses that keep this well-organized metropolis ticking along. Bulldog ants prove that being pocket-sized doesn't mean you're powerless. But there's a beast that ants would prefer not to run into: the antlion. It's not an ant, and definitely not a lion, and although it may not be as big as the king of the jungle, it's no less deadly. They are the larval form of a type of lacewing insect, and they are an ant's worst nightmare. Because antlions build death traps for their unsuspecting prey. They live buried in the sand, where the larvae dig funnel-shaped pitfalls with such efficient construction, it would put an architect to shame. The slope is steep enough to guide prey to their mouths, but shallow enough to avoid avalanches. The trap's sides are set at a perfect angle. When prey falls in, it has no way of getting out. Thanks to the unique wave propagation properties of sand, antlions can make use of the sand-borne vibrations to sense when their prey is near. These vibrations are picked up by sensory hairs on the head and antenna. It seems the antlion's senses are perfectly in tune with its sandlocked life. Deep in the Namib Desert of southern Africa is another predator who detects prey from vibrations carried through the sand. These are sit-and-wait huntsman spiders, and this parched earth is their home. The Namib huntsmen live in burrows that extend diagonally into the dunes. At night, they hunt insects, waiting patiently for the telltale signs of dinner as it crosses the spider's domain. Elongated hairs, called trichobothria, line the antenna-like pedipalps and legs. These sensory hairs are stimulated by air currents and low-frequency vibrations. The spider waits until the subtle tremblings of the sand signals its prey is nearby. then darts out to ambush the victim. During the day, dune spiders escape from the heat of the sun by staying underground, only coming out to repair or construct their lair. It's not easy to dig tunnels in the shifting sands, but the spider succeeds by lining the walls with silk. And it's at this point that the spider is at its most vulnerable. Their archenemy is a pompilid wasp, a parasite with a predilection for laying its eggs inside the spider's body, so the hatchlings have fresh and living meat to feed off. But all is not lost because this particular dune huntsman has a nifty escape plan. If its burrow happens to be on the side of a steep enough sand dune, it takes off and effectively invents the wheel. The spider rolls onto its side, tucks in its legs, and cartwheels down the slope, accelerating to a speed of more than 1 meter per second. That's the equivalent of a car traveling at 300 kilometers per hour. This species is not known as the wheel spider for nothing. Brush turkeys seem to have embraced the idea of modern man, because in this bird's world, it's the male that does the housework and looks after the kids. Male turkeys build large mounds comprised of decomposing vegetation, leaf litter, and soil. The suitor with the best maintained mound gets the girl. Females lay their eggs and then leave, and it's left to the fathers to look after the young. As the decomposing vegetation produces heat, it incubates the eggs. Keeping the right temperature is vital for their offspring's survival. So males check the warmth of the composting by inserting their heads in a hole. To keep a constant 33 degrees Celsius, the turkey removes or adds layers to the mound as needed. They can take the temperature by using highly acute heat sensors inside their upper bill. Without the brush turkey's bill thermometer, the embryos wouldn't develop. It's thanks to their super heat sense that a new generation is born. The senses are the stars on animal supersenses. We've learned digging deep doesn't stop animals from sensing their surroundings and making the most of what the earth has to offer. Join us next time on Animal Supersenses to find out more incredible powers of animal perception.